Alright guys, welcome to today's class. Today we're going to continue our lesson off and then start our homework. And then continue on today's lesson. Let's get started. Example 13. If k is a positive integer divisible by 3, and if k is less than 80, what is the greatest possible value of k? Well, we know that k has to be divisible by 3 and k has to be less than 80. So let's start from 79. Well, notice that 79 is not divisible by 3. Here we can rule this out because the sum of the digits is not divisible by 3. So then we do 78. And this number is divisible by 3. So the sum of the digits is 15. It's also divisible by 3. So the greatest possible value of k is D, or 78. Now let's do example 14. Which of the following numbers can be used to show that the statement below is false? All numbers that are divisible by both 2 and 6 are also divisible by 12. I'll let you guys have a go with this question and tell me answers through chat. Alright, let's just start with example 14. Which of the following numbers can be used to show the statement below is false? Right. All numbers that are divisible by both 2 and 6 are also divisible by 12. Well, we can have a number that's divisible by 6, but not divisible by 12. We can notice that. Since 2 divides into 6. Or 6 is divisible by 2. So notice that out of all these options here, one is strictly divisible. One of them is strictly divisible by 6, but not divisible by 12. Which is C, or 18. So the answer to this question is just C. Alright? Let's do example 15. On a square game board that is divided into n rows of n squares, each k of these squares not lie along the boundary of the game board. If k is one of the four numbers below, what is the possible value of n? Let's get a try on this question and tell me answers through chat. Alright guys, let's get started with this question. So the answer is C. We can find out by testing the values that we find out that the total area, the n row of n squares each, is the total of n squared. And notice that the outer edge is 4n minus 4. Since there's, so over here we have n over here, n, n, n minus 2, n minus 2. That's 2n plus 2 times n minus 2, or 4n minus 4. From there, we notice that we can subtract this entire thing from the total area to get k, or which is n squared minus 4n plus 4. So then we get that this should be equal to 25. We can let this be 25. Or whatever number we want. Alright? Or the second way, you can do algebraic manipulation. Or the second way is just to try out every single value. Alright, for 10, you can see that it doesn't work. 25, same thing. I mean, for 10, it doesn't work for here. 12 also doesn't work. Then we try 14. Alright? So we know that if we let n equals 14, that would be a total of that would be 14 by 14. Oops. I think they worded it wrong since 52 is not going to be close to 14. Alright? So I'm pretty sure they meant to word it as not lie. I mean, I think it's meant to say lie along the boundary of a game board. So if it was like that, then the answer would be C. Since there is a total of 4 times n minus 1 on the boundary, so that if we test everything out, we get, if we have 14, the total number is going to be 4 times 14 minus 1, or 13, or 32, which will be IV, and then the answer is going to be C. Alright, so there's a major incorrect wording over here. So, sorry about that. Now let's do example 16. A student practices the 4 musical notes as shown below, starting with the note furthest left and continuing in order from left to right. If the student plays these notes over and over according to this pattern and stops immediately after playing the shaded note, which of the following could be the total number of notes played? Let's go have a try on this question and determine this through chat. Alright guys, let's get started with this question. So basically notice that it could be repeated for 4 times every time. And then at the a bunch of 4 cycles, the cycle of fours, we stop at a black one, that would be 1 and 2. The last cycle will not be completed. Instead, there will be 2 left over. Right? So I know that the remainder when the number of notes we went through divided by 4 is 2. So basically from here we can notice that this is divisible by 4. And so is that. This is 1 more than a multiple of 4. And this is 3 more than a multiple of 4. Notice that this is a 2 more than a multiple of 4. So we know that A is our answer here. Since we go through 4 cycles of 4 every single time, till we stop, it'll be 1, 2. So it'll be 2 extra for the cycle of 4s. A bunch of cycle of 4s. N times. Say it goes N times. See that it's 2 more than a multiple of 4. Alright? Now let's do example 17. Which of the following statement can be used to determine if a number is divisible by 54 or not? I'll let you guys have a try on this question and try to answer your chat. Alright guys, let's get started with this question. So notice that we want to try to find the conditions that actually make a number divisible by 54. So let's get started. Well, the number must be divisible by both 6 and 9. Can that be true? Well, let's try to test it out. Say we have this number 18. 18 is divisible by 6 and 9, but it is not divisible by 54. We have a number, also have 36. 72 also doesn't work. So we can rule out 1. The number must be divisible by both 3 and 18. The same thing, doesn't work. Since both of them are divisible by 3, so the only thing we're making it divisible by is only 18. And that does not really make us any number divisible by 18 divisible by 54. 3, however, works. Why? Because the number must be divisible by 2 and 27. 2 and 27 are not the same, aren't share a factor of 1 with each other. They're co-prime, or they don't share any factors with each other. So, if we do find the least common multiple, that's going to be 54. So if the number is divisible by both 2 and 27, then it's also divisible by 54. So the answer is B. Now let's move on to example 18. For what digit x will the 7-digit number 3xx6xx2 be divisible by 4? Let's guys have a try on this question and tell me the answer to chat. Alright, let's get started with this question. So basically, how do we approach this? Notice that 7-digit 3x6x2 must be divisible by 4 only if the last two digits are divisible by 4. So we can ignore all of this and only concern about ourselves x2. Now, what two-digit numbers that end in 2 are divisible by 4? Well, there are notably 2, 32, and 72. Those are the only two. So there's only two digits. So the answer is C. Oops. I don't know the question. This is for one digit, so not the number of digits. So it's 3 and 7. 3 and 7. So which means that 3 works out of all of these options, since there's no 7. Right? Now let's move on to problem 15. How many numbers less than 100 are divisible by and divisible by 3 are also divisible by 4? This is just telling you that we want all the numbers divisible by 3 less than 100 that are also divisible by 4. So they're all in total divisible by 12. How many are there? There are a total of 8. There's 12, 24, 36, all the way to 96. There's a total of 8, so the answer is C. Alright? Now let's move on to problem 16. There are 24 four-digit numbers, which are used each of the digits 1, 2, 3, and 4. How many of these are divisible by 11? Well, notice that there are 4 total digits. And all of these digits are divisible by 11. So this is what they're asking for. They're asking basically all for the sum of all the odd place digits and even digits to be the same. Naturally, there are only one way to do this. There's only one possible way to do this. 4, 2, 3, 1. It has to be 4, 2. The pair has to be 4, 2, and 3, 1. I mean, 4, 1, and 3, 2. My bad. So that's 4, 1, and 3, 2. So these have to be the pairs. Notice that they're alternating. So we have these digits. We can place 4, 1 over here, 4, 1 over here, and place 3, 2 over here, and 3, 2 over there, respectively. So that's two possible ways. Now now that's two ways for 4, 1, and 2 ways for 3, 2. Now each of these two ways, we can flip them over to become 1, 4, not 4, 1. So we can multiply the 2 plus 2 by another 2. This just gives you a total answer of 8. So the answer to this question is just E. Why is that? Because notice that talked about like last lesson and last of last lesson. Notice that a number is divisible by 11 if the sum of the first, third, fifth, and so on digits is equal to the sum of the second, fourth, and so on, sixth digit, and so on. So from there, we can notice that the only digits there that can possibly happen is 4, 1, and 3, 2. And we can flip them over to get 1, 4, and 2, 2, 3. Alright? So from there, the answer is 8. Alright? Now let's move on to problem 17. Find a digit D that makes the 3-digit number 2d6 a multiple of 22. I'll let you guys have to try on this question and tell me answer to your chat. Alright guys, let's just start with this question. So basically, D has to be A or D. Why? Because since this has to be 20 divisible by 22, and we already know that last digit is already divisible by 2, notice that these are alternating. This is the first and third digit, and this is the second digit. We want this to alternate. So that's just 2 plus 6 has to be D. So the answer is just D equals 8. Now let's do problem 18. A 4-digit number uses the digits of 1, 2, 3, 4 exactly once. What is the probability that the number is multiple of 4? Well, first of all, notice that the last two digits have to be divisible by 4. Though, how do we do that? There's only two possible last digits, 2 and 4. Respectively, we get 3 and 2 for the last two digits. Now notice that we can have any of the other digits to be in the over here. Any choices. So there is a total of 2 choices with this one and 2 choices with this one. So that's a total of 4. Divide that. We also missing 12. My bad. We add in the 2. Another 2, that'd be 6. Divide by 24. That's going to be 1 over 4. Or D. Make sure you count all the cases. And double check to make sure your answer is correct. Right? Now let's do problem 19. What is the greatest 3-digit number that is divisible by 6? Well, we've done this before. This is just 996. Why is that? Because the last digit has to be divisible by 2. And the sum of all digits has to be divisible by 3. And this satisfies the requirement. The answer is D. Right? Now let's move on to example 19. What is the largest digit which can replace B to make the number 437B32 divisible by 3? Adding all these digits up, we get 19 plus B is equal to K. So minus digit. Alright. And we know that K has to be divisible by 3 since the number is divisible by 3. The 437,000B32 must be divisible by 3. The only way to make this possible is if we let B equal to 2, which gives you 21. If we add another 3, this is going to be 24. So B is 5. And add another 3, we get 27, or B is 8. So there is a total of 3 digits, and the largest is going to be E, or 8. Now let's move on to example 20. The 3-digit number 2A3 is added to the number 3D6 to give the 3-digit number 5B9. If 5B9 is divisible by 9, then A plus B equals... Alright, so we want to try to find B and A. So let's just add up 2A3 and 326 to see what we get. Notice that we have no regrouping here. This gives you 5, A plus 2, and 9, which is just 5B9. And we know that the 5B9 is divisible by 9. From here, we get B is equal to A plus 2. But notice that 5B9 is divisible by 9. So we know that 14 plus B, the sum of the digits, must be divisible by 9. Some number 9 times n. N, which a random number. Notice that the greatest number B can be is 9. So the only possible value for B is just going to be 4 to get 9 times 2, or 18. If B is 4, then A is 2, and adding these both up give you 6, or C. Right? Now let's move on to example 21. I'll let you guys have a go with this question and tell me answers through chat. Alright guys, let's get started with this question. So basically, A and B are non-zero digits for which A468, B05 is equal to 11. As we did before, every other digit, sum with this every other digit, must be the same. From there we get 12 must be equal to A plus B plus 11. Right? Or we can say it a different way, or A plus B plus 11 minus 12 must be divisible by 11. From there, it's easy to see that it becomes A plus B minus 1, which then has to be divisible by 11. From there, we get A plus B is equal to 12. So the answer is just E. Alright? So that's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye.